점수 잡는 hackers.
Questions 12 and 13 both refer to this histogram here. So it's a frequency distribution. Does that make sense? So time from 0 to 1 hour studying, we have 6 students, 10 students, 8, 5, 2, and 1 respectively. If you were solving this question, I think you should have labeled the numbers here, right? You have, I'll just write it on top. 6 students, 10 students, 8, 5, 2, 1. Okay, so let's read the first question. Number 12, they said, a student is selected at random from among those surveyed. So you would add all the number of students here. What do you get? The total sum of 10, 20, 32. And they're asking for the probability that he or she does not spend more than 2 hours on their homework every day. So maximum of 2, less than or equal to 2. So you would add these two blocks here. You get a total sum of 16. And I think we have an answer choice. You don't need your calculator. What do you get? 1/2. Good. So you circle B. Okay. So let's move on to number 13. Which of the following could be the mean length of hours the students included in the survey spend on the homework every day? So this question was a bit tedious. You had to do a lot of calculations with your calculator. So let's go back to the histogram real quick. Students spending between 0 to 1 hours, 1 to 2 hours, 2 to 3, 3 to 4, 4 to 5, and maximum. So I guess since they're asking for an approximation, you have to break this down into 2 scenarios. Either considering the lower limit for the respective time frames or the upper limit. And you're looking for the value that falls in that region, the range. Does that make sense? So for instance, if I were to approximate using the lower limit, let's just label it L, and then upper limit, how do you find the average number of hours per student? You would take the sum of the number of hours they studied, you divide it by the number of students, and that's how you would proceed, right? So in the denominator, you get a value of 32, which we did find from our previous question, and you have to add the respective times. So lower limit means 6 students studying 0 time or 0 hours, and then you have 10 students studying an hour, 8, 2, 5, 3, 2, 4, and then 1, 5. And that's what you would plug into your calculator to find your lower boundary, okay? And your upper limit, it's the green ones, right? I'll just write it out for you. So the same number of students, 32, but the number of hours is going to be the maximum, the extreme. So 6 students studying for an hour, 10, 2, and you plug this in. So let's just define this to be A and this to be B. So whichever falls within the range of A and B is your correct answer. And you guys can finish this up, right? What did you guys get for your correct answer? B? No? Very good. So let's move on to number 14. They have a table provided, input, function, right? And they're asking for f of g of 2. It's a composite function. How do you approach this question? You have to solve for the innermost function here. G of 2 simply means when x has a value of 2, the output value of 4 is your overall expression. So you have to further calculate or find the value of f of 4. x4, y, 5, and that's it. Okay. Number 15 through 17 both refer to this scatter plot here. Scale radius in millimeters. Y is the body length in millimeters. Let's begin our first question. According to the line of best fit, the body length in millimeters of largemouth bass with a scale of radius 12 is how much greater than the body length of largemouth bass with a scale radius of 8? So what do? You go back to your graph here. We're looking for the difference of 350, 250. I think we're done, right? 100, B. Okay. So number 16, the fisheries manager models the line of best fit by the equation where L represents the body length, S represents the scale radius, and A, K are both constant. So it's a linear representation of the graph we were looking at. Interpretation of K here. Well, that's going to be the slope value, right? So among the answer choice, you have to find a description that tells or talks about the slope here. But when you go back to the graph, I think we do have to find the numerical value that it corresponds to the slope. So you have a positive value. Should we just take these 2 points, for instance? So when we're increasing the x unit by from 5 to 6 to 10, when there was an increase of 4, the y unit had an increase of 100. So we can see that as the scale radius increases by 1 unit, there's going to be an increase of body length of, 25 millimeters? So when you look through the answer choices, I think you get a correct description. Increase of 25 expected for 1 millimeter for scale radius. It's just the basic interpretation of a slope, right? Let's move on to the last question for this basic setup. They said they estimated the age of each bass in the sample by counting the number of rings, all in a scale from each fish. So from the previous table, they provided different information, right? They had scale radius and body length, but they're incorporating new information of age. So years 1 through 7, and that's the body length that they provide. So when you read number 17, they say that a scale radius of 14 millimeters is estimated to be 8 years old. So let's just write it out. Scale radius of 14 millimeters is estimated to be 8. What is the best approximate of 8? So I think we have to go back to our graph here. When we have scale radius, that's the x-axis, to be 14, it refers to body length of about, can you guys tell me? 400? Yeah. Body length of 400. So what do? You look at the table. 40 is going to be between 6 and 7. So that's why C is the correct answer choice. Okay? Very good.